The neighbor decided to buy cell phones for her family of 4. Each cell phone plan costs 10 cents per text message plus a $20 monthly fee. Each family member is allotted the same number of texts per month. If T represents the number of texts per family member each month, write an expression that represents the total cost for the family of 4. Use your expression to predict how much the neighbor will pay, or the neighbor's bill will be if everyone in her family sends 35 texts per month. So we know that it's 10 cents per text plus a $20 fee. So this could be our expression. But there are 4 family members, so we would need to multiply all of that by 4 so that every member in the family is counted. We can then use the distributive property to share the 4 with the 10 cents per text message and the $20 monthly fee, giving us 40/100ths T plus 80. So let's use our expression to predict if we were to send 35 texts per month. So we will replace the text message piece with 35. 40 cents times 35 messages is 14, plus 80 is 94. An area model is given below. Select the expressions that could be written using the diagram. So I see I have 1, 2, 3, 4 Y's and 1, 2, 3, 4, 5, 6, 7, 8 X's. So 4Y plus 8X would be appropriate. Here's 4Y, but then it has plus 2X, so it's not counting these 6, so B is not correct. 4 times Y plus X. Well, we do have 1, 2, 3, 4 groups here, but each group is Y plus 2X, not just Y plus X, so C is not okay. Further, 4Y times 2X. Yes, we have the 4Y, but there is more than 2X across the top, so D is not appropriate. Letter E would work because we have 4 groups of Y plus 2X. And F is Y plus 2X plus Y plus 2X plus Y plus 2X plus Y plus 2X. So that, of course, will work as well. So A, E, and F will all work. Solve the following equation using the distributive property. So 3 times the quantity, 3x plus 2, is 24. So we need to share and distribute the 3 with each piece, giving us 9x plus 6 equals 24. Now, using the same operations on both sides, we will subtract 6 from both sides, giving us 9x equals 18. Dividing each side by 9, not by 2, gives us x equals 2. Let's verify this using algebra tiles. Here are algebra tiles. I have set up 3 copies of 3x plus 2, so I have 3 of those copies, is equal to 5, 10, 15, 20, 24. So the first thing we would need to do is use the distributive property, but there's not much to distribute here because I already have it all laid out. So then what we need to do is we need to subtract 6 from both sides so that we can get these into copies of 0. So I'll add 1, 2, 3, 4, 5, 6. So by adding copies of 6, we know that these all here will just end up canceling out to be 0. And I can do the same here. 1, 2, 1, 2, 1, 1. Okay, now we still have 9x and we have 5, 10, 15, 16, 17, 18. Oh, I must have taken one too many away. No, 18 is right. 5, 10, 15, 16, 17, 18. Okay, so now let's see if we have these 9, how can I evenly divide up those 18 so that each x has the same amount of units? So I'll just start lining them up here. Kind of try to make them even. So it looks like each x value is equal to 2. So each x value equals 2. The perimeter of the larger square is 84 units. What is the perimeter of the smaller square? We know that perimeter is the same as adding all of our sides together. And we know that it has to equal 84. So 2x minus 1 plus 2x minus 1, etc. Knowing that there are 4 copies of the same thing, we can use the distributive property. After distributing the 4, we end up with 8x minus 4 is equal to 84. Using the same operation, we will add 4 to both sides, giving us 8x equals 88. Dividing both sides, we see that x is equal to 11. Now we can identify the perimeter of the smaller square, knowing that the value of the smaller square is adding up all their sides, so x plus x plus x plus x, or there are 4 x's. Substituting in 11 for x, we get 4 times 11, which is 44 units. Arithmetic and algebraic approaches to solving problems are related, and both approaches can be written as equations. So Diego, Robbie, and Omar made flashcards for 60 science words. Robbie made 5/6 as many as Diego, and Omar made 4/5 as many as Robbie. How many cards did each person make? So let's start with Diego, Robbie, and Omar. So Diego made 5 out of 6. Okay, so Robbie made 5/6 as many as Diego. Omar made 4/5 as many as Robbie. So Diego has 1, 2, 3, 4, 5, 6. Robbie has 1, 2, 3, 4 fifths, and Omar has 1, 2, 3, 4. So it kind of builds this little tape diagram. And altogether they had 60. So if we're thinking arithmetically, Diego had 6, 1, 2, 3, 4, 5, 6 altogether. Robbie had 1, 2, 3, 4, 5, and Omar had 1, 2, 3, 4. So altogether they had 15. So if I take the 60 and divide it by the 15 cards, each one represents 4. So then Diego has 4 times 6, so each one of these blocks represents 4. So 4 times 6 is 24, 4 times 5 is 20, and 4 times 4 is 16. We could do this algebraically as well. If we were to let C represent the number of cards they have, we would have 6 cards plus 5 cards plus 4 cards must be a total of 60. Combining like terms, 15 cards equals 60. Dividing each side by 15, each one represents 4. So notice that whether we do arithmetic or algebraic, we are still adding and we are still dividing. Homework. Use the digits 1 through 9 at most one time each to create an equation where x has the greatest possible value. Use algebra tiles to justify your answer. I'll upload all of your work and your solution to the Create an Equation discussion board. Please also include all the attempts that you tried because it's part of your thought process. And respond to 2 classmates' strategies for their solution. The value of one expression may be less than, greater than, or equal to the value of another expression. Write the following description algebraically. 10 subtracted from 4 times a number is less than 3 more than 2 times that number. And 5 more than half a number is no more than 6 less than that number. That's a lot of words going on, so let's break it down. So this first one is less than. So we have 2 pieces that it's less than. 10 subtracted from 4 times a number is less than 3 more than 2 times that number. So we're going to let n equal that number. So we can, on the left-hand side of our is less than symbol, write 10 is subtracted from, so something minus 10, and that something is 4 times a number. On the right-hand side then, 3 more than, so plus 3, 2 times that same number, 2n plus 3. So in the second one here, we have the is no more than, and then it's broken up into 2 separate pieces. So 5 more than half of a number, so plus 5 more than half of a number, so 5/10 of an n, is greater than 6 less than that number, so the number minus 6. Inequalities can be solved using the same kinds of operations used for solving equations. Use a number line to model and solve the following. So I have n over 3 plus 2 is greater than 0. So right now we have an open dot because we have a greater than or less than symbol. And currently it's greater than 0, so we want things that are bigger than. So then our next step would be to subtract 2. So I'm going to move my dot to the left 2 so that we subtract 2. Now we're at negative 2. So n over 3 is greater than negative 2. But to get n by itself, we know we need to multiply both sides by 3. So if I multiply negative 2 by 3, we get to negative 6, but we're still moving in that direction. So n is greater than negative 6. Use a number line to model and solve the following. 1/2 of x plus 3 is less than or equal to, or minus 4 is less than or equal to 7. So this time our dot is filled in because it's less than or equal to, and less than is traveling left on our number line. We would want to add 4 to both sides. So from 7, moving it 4 units to the right because we're adding 4, 7, 8, 9, 10, 11. After that, we would want to multiply both sides by 2 so that we can get rid of the half. So 11 times 2 brings us to 22. And after that, we want to subtract 3 from both sides so that we get our x by itself. So 22, 21, 20, 19, and we're still facing the left-hand side there. And just to work through it algebraically here, so the first thing we did was we added 4 to both sides, giving us 1/2 times x plus 3 is less than or equal to 11. We then multiplied both sides by 2, so then we were left with x plus 3 is less than or equal to 22. Subtract 3 from both sides, so x is less than or equal to 19. There may be infinitely many numbers that satisfy an inequality, which can all be shown using the number line. Solve and graph the inequality. I'm going to multiply by its least common denominator between 2, 4, and 1. So when I multiply everything by 4, even that 5 gets multiplied by 4, even though it doesn't have a fraction. Gives us 60 halves is greater than or equal to 4d over 4 minus 20. I can actually divide them through to get whole numbers. So 30 is greater than or equal to d minus 20. We need to get d by itself, so we're going to add 20 to both sides. So 50 is greater than or equal to d. Because we have a greater than or equal to sign, we will have a solid dot at 50. Now we need to determine which way our arrow will go. So I like to pick a point like 0. Is 50 greater than or equal to 0? True. Is 60 greater than or equal to 0? That's false. So our arrow needs to go left. Needs to be where all the true values are.